Yes. So in this session, we are going to see PySpark with AWS. So first we are going to understand what is PySpark and what are different components available in PySpark. And next we are going to discuss AWS introduction and AWS services brief introduction and how we are going to use PySpark with AWS. Okay, so let's start it. So first we are going to understand what is PySpark. Do you have any idea what is PySpark team? Hello. Do you have any idea what is PySpark team? No? Okay. So first important point, PySpark is a data processing framework. The first important one, it is a data processing framework. It does not have any storage. Any storage. So it's purely data processing framework. It's purely data processing framework. Like Hadoop, if you know Hadoop has both storage and processing. Yes or no? But PySpark is purely data processing framework. It does not have any storage. The main advantage of PySpark is it can process any data type. It can process any data. It is not tightly coupled with a particular file system. It can take any data as an input. It can perform processing and result we can write into any output storage. So it's purely data processing framework. Let's diagrammatically discuss it. So first one, PySpark application. Let's take PySpark application. So PySpark application means Python with the PySpark API. Spark with Python team. Spark with Python. So Spark provides API for different languages team. First important point. Spark provides Apache Spark provides API. Any idea what is API team? API stands for Application Programming Interface. Application Programming Interface. So which contains predefined classes, comma, variables, functions, and variables. So by using this predefined classes, functions, variables, we can develop Spark application. So this API, Apache Spark provides API for Python language. So if you write Spark applications using Python language, we call it as PySpark. So PySpark means Spark with Python. So here we write complete data processing logics. So we write complete data processing logics here team. There is no storage. So it's purely data processing framework. Next important one, it is not tightly coupled with any input file system. So you can take any input. You can take anything as input and you can write output into any output storage. It is not tightly coupled with any input and any output. Let's say So we have different inputs like local file system, and HDFS file system. Next one, cloud file systems like AWS S3, or we can say uh, Azure file system, any file system, any cloud file system. And next one, Apache Hive. And next one, any RDBMS, like MySQL, PostgreSQL, Oracle, any RDBMS team, any NoSQL database. So we have different NoSQL databases. Tell me any NoSQL database team. MongoDB, Apache Cassandra, Apache HBase. We have different databases. Yes or no? So any NoSQL database you can provide as input. Any streaming framework. Any streaming framework means we have Apache Kafka, AWS Kinesis, Azure Streams, GCP Streams or PubSub. Any streaming framework as a input team. Okay, so we can say any data. We can pass any data as a input. Similar way, output also same thing. Output also you can give anything. So there is no particular storage. You can give anything as input, anything as output. So it will take local file system. It will take HDFS file system. It will take any cloud file system. It will take Apache Hive. It will take any RDBMS data. It will take any NoSQL data as input. It will take any streaming framework. It will take any data as an input. Finally, it will perform processing. Results it will write into what? Any of these things. Local file system. So once data processing is completed, output of this PySpark, you can write into any of these storages. So you can write output into local file system. You can write output into HDFS file system. You can write output into any cloud file system. You can write output into Apache Hive. You can write output into any RDBMS. You can write output into any NoSQL database. You can write output into any streaming, and you can write output into any storage. It is not tightly coupled with any storage stream. So PySpark can process any data. PySpark can process any data, and 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 it can store results into any storage. It is not tightly coupled with any file system. So you can say local file system. You can give input as HDFS file system. HDFS file system means Hadoop file system thing. You can give input as Apache Hive. You can give input as any cloud file system. Like AWS S3, Azure file system, GCP file system, anything thing. Next, you can give any RDBMS like MySQL. Oracle, PostgreSQL, any RDBMS as input, any RDBMS as output storage stream, any NoSQL database. So we have different databases, NoSQL databases like MongoDB, Apache, Cassandra, Apache Cassandra. Next one, Apache HBase. So we have different NoSQL databases. You can give any streaming framework to it. Any streaming like Apache Kafka, AWS Kinesis, and Azure Streams, GCP Stream. You can give anything as input. So any storage, there is no tightly coupled thing. It can connect any input storage and it can write output to it. It's purely data processing framework. It does not have any storage. And one more important point here is, PySpark, Apache PySpark is a in-memory computing. Any idea what is in-memory team? In-memory means RAM memory. So it uses RAM memory. So compared to disk memory, in-memory is very faster. So before PySpark, MapReduce is the fastest processing framework. Compared to all existed traditional technologies, MapReduce is the fastest processing technology. It is proven team. Compared to MapReduce, Apache PySpark is 100 times faster than MapReduce in memory. So it is a pure in-memory computing. By default, it uses in-memory team. We can also configure disk memory. In disk memory also, compared to MapReduce, it is 10 times faster. And one more important point is Apache Kafka has Apache PySpark has different components. Apache Kafka has different components. There. So first important component is Apache PySpark core team, or we can say PySpark core programming core. Here we write RDD programming team. RDD programming means we have a transactions, transformations, and actions team. RDD programming means transformations and actions. So we write pure complete transformations and actions using Python language. So first important component, PySpark core. Here we write RDD programming. RDD stands for Resilient Distributed Dataset team. What is the advantage of RDD? RDD is highly fault tolerant team. Highly fault tolerant. How it is achieved? Highly fault tolerant. First, let's understand here. R means resilient. D means distributed. D means dataset. Dataset means our data. D means distributed. Your data splitted into multiple partitions, then that is distributed into multiple missions. Let's say you have a Spark cluster with 100 missions. So your data distributed across your cluster team. Okay, we created RDD. Let's say we created RDD, middle, some partition is failed. Then Spark will recreate. Resilience means recreation. It will recreate automatically. As a programmer, we least bother about this RDD. Spark will take care. Spark architecture, internal architecture will taken care to recreate RDD. So these transformations and actions we implement using Python language. So for this one, Spark provides API team. Spark provides API, core API. Okay. Next important component team, very important component, PySpark SQL team. In PySpark SQL, we have a concept called data frames, tables, and data sets team. Data sets. This data sets concept not available in PySpark team. This data set concept available in Spark with Java, Spark with Scala. Dataset concept not available in PySpark. There is a reason. When we are starting discussing PySpark SQL, I am going to cover. I am giving one important note, type safety. The main advantage of datasets are type safety. Type safety means, let's say you are creating one dataset with integer data type. So you can store only integer data into that data set. You cannot store string data. You cannot store Boolean data. You cannot store other data. Means type safe. In Python, we do not have a data types. Data types are there, but those are dynamic types. Python is a dynamically typed language. Type based on the value we are passing to variable. Yes or no? So we do not have a type safe concept here. We have in PySpark, we have only data frames and tables team. On data frames, there is a concept like here transformations and actions, right? Here we have programming concepts, DSL. DSL stands for domain specific language, and native SQL team. Native SQL means SQL team. This DSL we can apply on data frames. Native SQL means SQL. We can apply on tables. Then we have already PySpark core programming for data processing. Why they invented PySpark SQL? So first important point to team, in PySpark, we can provide data engineering solutions in two ways. One way is programmatic, second way is SQL approach. First way is programmatic approach. Second approach is what? SQL approach. Programmatic approach we can provide using PySpark programming. SQL approach we can provide solutions using PySpark SQL team. So here we use pure Python programming. Here we use very less Python and more SQL kind of programming thing. More SQL kind of programming. So we can provide solutions both programmatic approach and SQL approach team. Programmatic approach and SQL approach. Okay. So clear, right? Yeah. So next important component is third important component, PySpark streaming team. PySpark streaming. So PySpark streaming team, PySpark streaming, we write streaming plus live analytics. Live analytics. So stream means continuous flow of data. If any source continuously generating, example, web server. You have a web server, e-commerce web application deployed into that application. So multiple customers are connecting that application, doing lot of activities. One person browsing product, one person purchasing products, one person continuously adding products, removing products from cart. Some people browsing mobiles, some people browsing home related, some people browsing uh, teaching related products, etc. So this web application continuously generating logs somewhere, like a file system, log file system, that data continuously writing into log file system. So such kind of continuous data we call streaming thing. If any source generating continuous data, such kind of data we can say streaming data. So we can read the such kind of continuous streaming. Along with that one, we can provide live analytics team. Example, let's say uh, credit card fraud detection. So we are working for, assume we are working for HDFC Bank. HDFC Bank customer, example, XYZ customer did transactions in 2 different locations with the same credit card. Let's say one in Hyderabad, one in Bangalore. Then immediately bank people wants to notify that customer, a customer, you did 2 transactions from 2 different places. Is that you or someone? How it is possible? So whenever customer is doing transaction, we are getting continuous streaming data. On that data, we are doing live analytics and we are notifying customer. If customer says, yes, I did, then we will ignore that one. If customer says, no, I did not, then we will immediately notify that vendor. Yes or no? So such kind of analytics we can do by using PySpark streaming team. Yeah. So next important component team. Next important component, fourth important component, PySpark ML or mlib team. mlib. This one is complete machine learning library. Machine learning library team. So by using this machine learning library, we can implement machine learning applications team. So PySpark not provides all machine learning algorithms. Go with machine learning API, you can find what are algorithms it is supporting. Okay. What is the advantage of PySpark ML compared to pure Python ML? Just now we discussed PySpark is in-memory computing and it is 100 times faster than MapReduce. It is very fastest processing framework. So PySpark machine learning algorithms are executes very faster. And here these people provides API for RDD based, SQL based team. I said we can provide solutions in programmatic approach, SQL approach. So this library available both RDD based and SQL based team. Next important component is fifth important component, PySpark graphics. Graphics. So this one, by using this one, we can do graph data or linked data processing team. Linked data processing. Graph data or linked data means, let's take example social media team. In social media, assume one person joined in social media and he become friend to friend of your friend of friend of friend. Then you will get a mutual fund request. Yes or no? Such kind of linked data we can process easily using PySpark graphics team. Without graphics, we can do using programmatic approach, but we have to write complex algorithms. We have to write complex algorithms. Even if you write a complex algorithm also, you may not get the proper outputs. Such kind of complex problems, they provide a solution easily using this PySpark graphics team. Okay, so these are 5 important components. Let me diagrammatically explain to you. For all these PySpark team, so main important component is PySpark core programming team. First main important component is PySpark core programming. In PySpark core, we write RDD programming. Okay, so we write what? RDD programming. So first important pointer. Okay, next one, on top of this one, they have a abstraction team. They have abstractions. So first one, PySpark SQL. Next one, what? PySpark streaming. Next one, PySpark ML and graphics team. Okay, on top of this Spark core programming, we have abstractions. So first abstraction is PySpark SQL. Next abstraction is PySpark streaming. Next abstraction is PySpark ML or mlib. Next abstraction is PySpark graphics. Okay, so high level we say PySpark SQL streaming, PySpark ML or graphics, but low level those programs are converted into RDD stream. In RDDs we write lengthy programs. This Spark SQL reduces lengthy programs. Streaming also we can find RDD based, SQL based. ML also we can find RDD based, SQL based. High level we say PySpark SQL, PySpark streaming, PySpark ML, PySpark graphics. Low level those programs are converted into RDD programs. The main advantage of Spark is RDD team. RDD is a distributed data set and resilient. Because of this feature, RDDs are highly fault tolerant. Whenever you store data into RDD, your data divided into multiple partitions team. Yep. Okay. Clear writing? So PySpark graphics, PySpark ML, PySpark streaming, PySpark SQL, PySpark core. These are different components of PySpark. And the next important point thing, we can deploy PySpark applications. PySpark applications on first one, Spark standalone cluster. Okay. Next, Yarn cluster. Next one, Mesos cluster and Kubernetes cluster team. Kubernetes cluster. Okay. So we can deploy Spark applications on different clusters. Let me diagrammatically discuss. Spark standalone cluster. Next, Yarn cluster. Next, Mesos cluster. Next, Kubernetes cluster team. Kubernetes cluster. So once our development is completed, you can deploy Spark applications on any of these clusters. So let's say our development is completed. Once development is completed, you can deploy Spark applications on Spark standalone or Kubernetes cluster or Mesos cluster or Yarn cluster team. And one more important note to team. One more important note. At the time of development team, let's say you are developing PySpark applications. So you installed Spark software in your machine. You may have Windows, you may have Ubuntu, you may have Mac operating system for your development. So you install your Spark software into your machine. In your machine, you have local master. So we have local machine. So development time, we can we can run PySpark applications on local machine. It contains local Spark master. Local Spark master team. Development time. Only development time we use local. Runtime we use either Kubernetes standalone cluster, Yarn cluster, Mesos cluster, Kubernetes cluster. Yarn cluster also called Hadoop cluster team. Someone asking question. Sure, Vishnu. We will discuss. Yep. So first, let's understand what is PySpark. So up to now, clear, right, Tim? What is PySpark? Tim, did you understand what is PySpark? Okay. So one more important point I'm covering, Tim. Just now we discussed one important point. Apache Spark. Apache Spark provides API. Yes or no? API stands for Application Programming Interface. Application Programming Interface for 4 languages. 4 languages. So here, if Spark provides Java API, if you implement this one, then we call it as Spark with Java team. Next language, Scala language. If you implement Spark with Scala, we call it as Spark with Scala, or we can say Spark and Scala. Spark and Scala. If API used Python, if we use Python API, Spark with Python API, we call it as PySpark. Okay. If you use R language, then we call it as Spark with R or Spark. So total 4 languages it is providing. One more important point I am covering. Apache Spark software. Apache Spark software implemented using Scala language. Apache Spark software implemented using Scala language, but Spark provides API for 4 languages. It provides API for 4 languages. Is it clear to you? So if you implement Apache Spark programs or applications using Java language, we call it as Spark with Java. If you implement Spark applications using Scala language, we call it as Spark and Scala. If you implement Spark programs or applications using Python language, we call it as PySpark. If you implement Apache Spark programs or applications using R language, we call it as Sparker. Clear writing? What is PySpark? PySpark is purely data processing framework. It does not have any storage. It is purely data processing framework. And applications too. Coming to different use cases. So most of banking applications too. Banking applications and finance applications, healthcare applications, etc. Implementing using PySpark or Spark. Because here data generating huge volumes. If you use traditional technologies for data processing, they may take days time to process your data. It may take days of time. If data is smaller, like MBs, max GBs, then your data processing is good. If data goes to terabytes, petabytes, then they take longer time. Even if you implement multi-threading, maintaining or managing multi-threading is very difficult, and merging all thread output is very difficult. And you have to write very complex algorithm, but even if you write a complex algorithm, you may not get proper outputs. But Spark can process your data parallelly on multiple machines. The main advantage, whenever you store your terabytes of data into Spark data frames or RDDs, those are internally, it may be RDD, it may be data frame, it may be stream objects, low level, everything is RDD. Your RDD divided into multiple partitions, each partition going to place into different mission. Each partition going to process by multiple missions. Each partition processed by different mission across the cluster, and final output also combining and giving by Spark will taken care all these things. You least bother about all those things. You are going to develop a Spark application. You least bother about multi-threading all those. Internally, Spark will taken care, process your huge volumes of data sets. Majorly banking, finance, healthcare, stock market, these kind of applications are implementing using Spark. Maybe Spark with Java, Spark with Scala, Spark with Python, Spark with R. Initially, in 2016, people started implementing using Spark with Java team. Later, people moved to Spark with Scala. Last around 4-5 years onwards, people implementing most of data processing applications using PySpark. I'm not saying Spark and Scala is reduced. Spark with Java is reduced. I'm saying around 60% plus, 60 to 70% plus people industry using PySpark for data processing. Clear, right? What is PySpark? Yeah. Now let's understand. AWS. AWS is a cloud vendor. It is a cloud computing. Cloud computing. It provides different services. It is from Amazon. It is from Amazon, and it provides different services. Different services for different categories and different purposes. In different categories, they provide different services. At this point of time, we can see 200 plus services. At this time, AWS providing 200 plus services for different purposes like storage, structured format like RDBMS, NoSQL, data processing related, network related, multiple categories, multiple purposes, 200 plus services available. It's purely cloud computing. Yes or no? Just now I said we can run our Spark applications on any of these clusters. Yes or no? 90% these clusters instead of on-premise. On-premise means physical data centers. Instead of physical data centers, people are going for these kind of cloud computing. So we use AWS EC2, serverless architecture, etc. for setting our cluster. Maybe Spark standalone, Yarn cluster, Mesos cluster, Kubernetes cluster. For setting all these, we use AWS Cloud, and AWS also provide one important service called AWS EMR for running your AWS applications, Spark applications. Okay. So AWS is cloud computing. It provides different services. For setting our Spark cluster, we may use AWS, we may use another vendor. For setting your AWS services, we use what? AWS EC2. So coming to AWS with Python, PySpark with Python or PySpark with AWS. PySpark with AWS. So for setting cluster, maybe Spark standalone, maybe Yarn cluster, maybe Mesos cluster, maybe Kubernetes cluster, we use AWS EC2 service team. And one more important, we will get continuous data or huge volumes of data. There is one service called AWS S3, simple storage service. So we get continuous data. Sometimes we get data in structured form in databases. So there is one database service called AWS RDS. RDS provides MySQL, MariaDB, and Oracle. Microsoft SQL Server, Oracle database, etc. So you may get data in a structured form in any of this RDS database. So using PySpark, we are going to connect RDS database. We are going to process. We are going to take as input. We are going to process it. And sometimes we may going to get AWS Aurora database. You may get different AWS Redshift. You may get input from AWS Redshift. You may have a requirement to write output into AWS Redshift. And you return PySpark programs. You are setting an standalone cluster on EC2 or Yarn cluster on EC2, or we have one special service called AWS EMRT, Elastic MapReduce. You can create a cluster with AWS EMR, then you can deploy your PySpark applications into AWS EMR. AWS EMR provides runtime environment for your PySpark applications. Your PySpark applications team. Lot more services. There are plenty of AWS services. These are some important services we use PySpark with AWS team. You are writing PySpark applications in your developer mission. For that PySpark application, you are getting input as AWS S3. You are doing processing. You are writing output into AWS Redshift. Runtime environment, you are using AWS EMR. Let's say AWS S3 team. AWS or S3. S3. So you are getting files. You are getting huge volumes of files. Every hour data is coming. So here you are getting files. Let's say these files are, we can say, raw files. On these raw files, you are doing processing using PySpark. You are using PySpark. For runtime, for running this PySpark, you are using AWS EMR. Let's say for running these applications, you are using AWS EMR runtime environment. Then you are passing this input. So you are doing processing using this one. Temporarily, you are storing your files into your output into AWS S3. AWS S3. So this we can say stage area. In this stage area, you are writing output, let's say Parquet files. You are generating output as Parquet format. You are getting, assume you are getting .json. Okay, .json. You are getting .csv. You are getting .xml, etc. data. Okay, then you are doing processing and you are writing output as Parquet files. Parquet files. Output as Parquet files in staging area. And finally, you are validating whether you processed correct output or not. From staging area, you are validating whatever input data, whatever custom client requirement, you are generating proper output or not. Once staging area contain proper data, then finally you are writing output into AWS Redshift environment. AWS Redshift. This is one sample use case I'm saying. So final output you are writing into AWS Redshift in tabular format from this data analytics team. Data analytics team, maybe Power BI, maybe Tableau team. Those people going to connect with this AWS warehouse environment, they are generating reports. Okay, clear writing? Clear writing? So final output we are writing into AWS Redshift warehouse environment. This is one use case. So in this way, we will learn PySpark with AWS team. Yeah. Any query up to now, team?
When you want to take the files from on-premise to S3, AWS S3, so do you need to install anything on the on-premise machine?
No. You may use PySpark for loading your data into AWS S3, Python programs using
No, I'm talking. I'm talking when you want to copy the data from customer machine. So you get a files in the form of text or CSV files or Parquet files. Those files you need to copy to AWS S3. So what is that? So we have, when you create a pipeline, so is it pipeline can directly access the on-premise machine, or how does that happen?
It access S3 only. So S3, assume your data coming every day. So let's say you created a bucket. You created one bucket with date and time. Let's say today 13th, and month and year, month and year. With this name, you created one bucket. In that, every hour you are creating separate folders. So here from client mission, they may have a different techniques for loading data into here.
No.
As a data engineer, yeah.
The thing is, I'm not talking. So if someone puts directly into S3, that is okay, because you write in PySpark, you write the code and you do the process. But if customer puts onto the customer machine on the server, from there you need to copy into AWS S3. So when you want to access, because I know that you're already doing with a PySpark, so you can directly access the AWS S3. But how do you access the customer environment machine here?
Yeah, here that's what I'm clearly covering. As a data engineer, that is not our responsibility. Data engineer responsibility comes here. This is my input source. How this input source coming? We are checking this bucket format. This is our responsibility. For this purpose, they have separate.
Because as a data engineer, you need to create the pipelines also, right?
That I'm saying. This one you are saying. This purpose we may have different technologies for data input for this AWS S3. You may use Kafka, you may use Flume, you may use Scoop, you may use Python for getting data from client mission to this AWS S3. You may use Python Boto 3 API. You are connecting file locations. You are taking the data. You are putting the data into AWS S3. Let's say we are writing Airflow. Assume you are writing Airflow pipeline. In this Airflow pipeline, first I want to data ingestion. I have a data ingestion application. This data ingestion application, here we return xyz.py. This xyz.py connecting this location and loading this data into AWS S3. This is data ingestion pipeline. This one is data processing pipeline. So we are discussing data processing pipeline. Clear, friend?
Yeah.
I have one question here.
Yeah, sure.
So for the AWS services you listed here, why you have not listed AWS Glue ETL processing? Because that runs on PySpark now primarily.
Here I put a head. You can name. Here I put a heading PySpark with AWS, not AWS Data Engineering. So here we are completely purely using PySpark for data process, not any AWS Data Engineering services.
Okay, so I'm not able to understand the difference. When you do a data processing, it's a data engineering project, right?
Yep.
Because
we are using pure Python, PySpark for data processing. We are not using any AWS data engineering service like Glue, Athena, any data engineering service. We are using PySpark. That's
so
what
basically
runtime. Runtime.
Basically, sorry, go ahead.
Tell me. You can tell.
So basically, your idea is to make a deployment on a EMR cluster, bundle the product as it, and then run the Spark application on the EMR services, because it provides you the pre-configuration and everything, like instead of doing on the EC2, and then make sure that the data has been processed instead of using any services from engineering perspective, from which is provided by AWS.
Correct. Three ways we are going to see. One is on AWS. You are correct. On AWS, we are going to create a Spark standalone cluster. Spark standalone. We are going to create Hadoop cluster. We are going to see AWS EMR. Then this is our Spark application, PySpark application. This PySpark application you can deploy on any of this one. AWS Glue, Athena, those are serverless architecture. So we are.
So the third one is the first two.
AWS
one, right?
EMR.
Yeah, EMR will anyways rule out the first two because this will come with the pre-configuration deployment.
Yep.
You just have to create your Spark job, and with the yarn cluster, you can run the Spark jobs.
Yep. Sometimes people, they will create their own Spark standalone cluster and Hadoop cluster, or Spark with Kubernetes cluster.
Got it.
Kubernetes, pure Kubernetes cluster with the Spark software.
So this course will contain Glue or Athena, or it will not contain Glue Athena?
No, it's pure PySpark with the AWS integration.
Okay.
First, we are going to talk about complete PySpark, and then we are going to learn different AWS services. Then we are going to integrate those services with the PySpark, and we are going to see Spark standalone, Hadoop cluster, and EMR. These environments.
Got it. But as per the industry standards, like what I'm working right now here with various fintech companies or with the insurance company, usually if the data is huge, we work on the EMR cluster. Otherwise, we use AWS Glue or Athena. Now, trying to understand, because this course is mostly because of the standards of how we do an experiment in the organizations, right? The real-time deployments. So why you have chosen not to go into the Glue Athena side, because they are like very important right now. Those are the services which are used on day in and day out basis. So why you have chosen not to go with that and just showing the pure PySpark development with
here you can understand. First point, we are putting AWS with PySpark. So still we have two kinds of applications developing in real environment. One is using pure AWS data engineering. AWS data engineering. So they directly use AWS data engineering services like Glue, Athena, etc. service for data processing. Okay, this is one way. And second kind, PySpark with AWS or any cloud. So two kinds of applications are running. Your case, you are correct. Your application is running AWS data engineering. Some applications I directly worked on AWS data engineering. Some applications I'm working in this way on AWS EMR.
Got it. But I'm just bringing that point that if you use Glue, it will already provide you the
That's
Jupyter kind
separate course. Separate course.
Okay, you have a separate program for that.
Yes, separate program for that. This is PySpark with AWS program. Here we are going to first we focus on complete PySpark and then AWS services. In AWS data engineering, there we talk about less PySpark and more on AWS data engineering services.
Okay, got it. Sure. Thank you so much. Sorry, just one more curiosity. So, are you running that course as well right now, the Glue or
You
or
can
you are
contact management. You can contact.
Okay.
They will give.
Sure.
Yeah. Any other queries, team?